Can you tell the origin story of id Software? Again, one of the greatest game developer companies ever. It created Wolfenstein 3D, games that define my life also in many ways. As a thing that made me realize what computers are capable of in terms of graphics, in terms of performance, it just unlocked something deep in me and understanding what these machines are all about. As games can do that. So Wolfenstein 3D, Doom, Quake, and just all the incredible engineering innovation that went into that. So how did it all start?
So I'll caveat up front that I usually don't consider myself the historian of the software side of things. I usually do kind of point people at John Romero for stories about the early days where I, I've never been like, I've commented that I'm a remarkably unsentimental person in some ways where I don't really spend a lot of time unless I'm explicitly prodded to go back and think about the early days of things. And I didn't necessarily make the effort to archive everything exactly in my brain. And the more that I work on machine learning and AI and the aspects of memory and how when you go back and polish certain things, it's not necessarily exactly the way it happened. But having said all of that, from my view, the way everything happened that led up to that was after I was an adult and kind of taking a few college classes, deciding to drop out, I was hard Scrabble contract programming work, really struggling to kind of keep groceries and pay my rent and things. And the company that I was doing the most work for was a company called Softdisk Publishing, which had the sounds bizarre now business model of monthly subscription software. Before there was an internet that people could connect to and get software, you would pay a certain amount, and every month they would send you a disk that had some random software on it. And people that were into computers thought this was kind of cool. And they had different ones for the Apple II, the 2GS, the PC, the Mac, the Amiga, lots of different things here. So quirky little business, but I was doing a lot of contract programming for them where I'd write tiny little games and sell them for $300, $500. And one of the things that I was doing, again, to keep my head above water here, was I decided that I could make one program and I could port it to multiple systems. So I would write a game like Dark Designs or Catacombs, and I would develop it on the Apple II, the 2GS, and the IBM PC, which apparently was the thing that really kind of piqued the attention of the people working down there. Like Jay Wilbur was my primary editor and Tom Hall was a secondary editor. And they kept asking me, it's like, hey, you should come down and work for us here. And I pushed it off a couple times because I was really enjoying my freedom of kind of being off on my own. Even if I was barely getting by, I loved it. I was doing nothing but programming all day. But I did have enough close scrapes with like, damn, I'm just really out of money that maybe I should get an actual job rather than contracting these kind of one at a time things. And Jay Wilbur was great. He was like FedExing me the checks when I would need them to kind of get over whatever hump I was at. So I finally took them up on their offer to come down to Shreveport, Louisiana. I was in Kansas City at the time, drove down through the Ozarks and everything down to Louisiana and saw the Softdisk offices, went through, talked to a bunch of people, met the people I had been working with remotely at that time. But the most important thing for me was I met two programmers there, John Romero and Lane Roth, that for the first time ever, I had met programmers that knew more cool stuff than I did, where the world was just different back then. I was in Kansas City. It was one of those smartest kid in the school, does all the computer stuff. The teachers don't have anything to teach him. But all I had to learn from was these few books at the library. It was not much at all. And there were some aspects of programming that were kind of black magic to me. Like, it's like, oh, he knows how to format a track on a low-level drive programming interface. And I was still not at all sure I was going to take the job, but I met these awesome programmers that were doing cool stuff. And like Romero had worked at Origin Systems and he had done so many different games ahead of time that I did kind of quickly decide, it's like, yeah, I'll go take the job down there. And I settled down there, moved in and started working on more little projects. And the first kind of big change that happened down there was the company wanted to make a PC gaming focused subscription. Just like all their other, it was the same formula that they used for everything. Pay a monthly fee and you'll get a disc with 1 or 2 games just every month, and no choice in what you get, but we think it'll be fun. And that was the model they were comfortable with. And they said, all right, we're going to start this Gamer's Edge department. And all of us that were interested in that, like me, Romero, Tom Hall was kind of helping us from his side of things. Jay would peek in, and we had a few other programmers working with us at the time. And we were going to just start making games, just the same model. And we dived in, and it was fantastic.
So you have to make new games
every month.
Every month.
Yeah. And this, in retrospect, looking back at it, that sense that I had done all this contract programming, and John Romero had done like far more of this, where he had done one of his teaching himself efforts was he made a game for every letter of the alphabet. It's that sense of like, I'm just going to go make 26 different games, give them a different theme. And you learn so much when you go through and you crank these things out, like on a bi-weekly, monthly basis,
from
something
start
like
to
that.
finish.
Yeah.
So it's not like just an idea. It's not just from the very beginning to the very end. It's done. It has to be done. There's no delaying. It's done.
And you've got deadlines. And that kind of rapid iteration, pressure cooker environment was super important for all of us developing the skills that that brought us to where we eventually went to. I mean, people would say like in the history of the Beatles, like it wasn't them being the Beatles, it was them playing all of these other early works, that opportunity to craft all of their skills before they were famous, that was very critical to their later successes. And I think there's a lot of that here, where we did these games that nobody remembers, lots of little things that contributed to building up the skill set for the things that eventually did make us famous.
Yeah, Dostoevsky wrote The Gambler. I had to write it in a month just to make money. And nobody remembers that probably because he had to figure out, because it's literally, he didn't have enough time to write it fast enough. So he had to come up with hacks how to actually literally write it
again
fast
comes
enough
down to
within
that
a
point
month.
where pressure and limitation of resources is surprisingly important.
Yeah.
And it's counterintuitive in a lot of ways, where you just think that if you've got all the time in the world and you've got all the resources in the world, of course you're going to get something better. But sometimes it really does work out that the innovation's mother of necessity, and where you can, resource constraints, and you have to do things when you don't have a choice. It's surprising what you can do.
Is there any good games written in that time? Would you say
Some of them are still fun to go back and play, where you get they were all about kind of the more modern term is game feel, about how just the exact feel that things, it's not the grand strategy of the design, but how running and jumping and shooting and those things I feel in the moment. And some of those are still, if you sat down on them, you kind of go, it's a little bit different. It doesn't have the same movement feel, but you move over and you're like, bang, jump, bang. It's like, hey, that's kind of cool still.
So you can get lost in the rhythm of the game, like is that what you mean by feel? So just like there's something about it that pulls you in.
Nowadays, again, people talk about compulsion loops and things, where it's that sense of exactly what you're doing, what your fingers are doing on the keyboard, what your eyes are seeing. And there are going to be these sequences of things: grab the loot, shoot the monster, jump over the obstacle, get to the end of the level. These are eternal aspects of game design in a lot of ways, but there are better and worse ways to do all of them. And we did so many of these games that it was, we got a lot of practice with it. So one of the kind of weird things that was happening at this time is John Romero was getting some strange fan mail. And back in the days, this was before email. So we literally got letters sometimes, and telling him, it's like, oh, I want to talk to you about your games. I want to reach out, different things. And eventually it turned out that these were all coming from Scott Miller at Apogee Software. And he was reaching out through, he didn't think he could contact John directly, that he would get intercepted. So he was trying to get him to contact him through like back channel fan mail, because he basically was saying, hey, I'm making all this money on shareware games. I want you to make shareware games, because he had seen some of the games that Romero had done. And, we looked at Scott Miller's games and we didn't think they were very good. We're like, that can't be making the kind of money that he's saying he's making 10 grand or something. off of this game. And we really thought that he was full of shit, that it was a lie trying to get him into this. But so that was kind of going on at one level. And it was funny the moment when Romero realized that he had some of these letters pinned up on his wall of like all of his fans. And then we noticed that they all had the same return address with different names on them, which was a little bit of a two-edged sword there.
Trying to figure out the puzzle laid out before him.
Yeah. What happened after kind of coincident with that was I was working on a lot of the new technologies where I was now full on the IBM PC for the first time, where I was really a long holdout on Apple II forever. And I loved my Apple II. It was the computer I always wished I had when I was growing up. And when I finally did have one, I was kind of clinging on to that well past its sort of good use by date.
Is it the best computer ever made, would you say?
I wouldn't make judgments like that about it, but it was positioned in such a way, especially in the school systems, that it impacted a whole lot of American programmers, at least, where there was programs that the Apple IIs got into the schools and they had enough capability that lots of interesting things happened with them. In Europe, it was different. You had your Amigas and Ataris and, Acorns in the UK and things that had different things. But in the United States, it was probably the Apple II made the most impact for a lot of programmers of my generation. But so I was really digging into the IBM, and this was even more so with the total focus because I'd moved to another city where I didn't know anybody that I wasn't working with. I had a little apartment. And then at Softdisk, again, the things that drew me to it, I had a couple programmers that knew more than I did. And they had a library. They had a set of books and a set of magazines. They had a couple years of magazines, the old Dr. Dobbs Journal and all of these magazines that had information about things. And so I was just in total immersion mode. It was eat, breathe, sleep, computer programming, particularly the IBM for everything that I was doing. And I was digging into a lot of these low-level hardware details that people weren't usually paying attention to, the way the IBM EGA cards worked, which was fun for me. I hadn't had experience with things at that level. And back then, you could get hardware documentation just down at the register levels. This is where the CRTC register is. This is how the color registers work and how the different things are applied. And they were designed for a certain reason. They were designed for an application. They had an intended use in mind, but I was starting to look at other ways that they could perhaps be exploited that they weren't initially intended for.
Could you comment on first of all, what operating system was there? What instruction set was it? Like what are we talking about?
So this was DOS and x86. So 16-bit 8086. The 286s were there and 386s existed. They were rare. We had a couple for our development systems. But we were still targeting the more broad. It was all DOS 16-bit. None of this was kind of DOS extenders and things.
How different is it from the systems of today? Is it kind of a precursor that's similar?
Very little. If you open up command.exe on Windows, you see some of the remnants of all of that, but it was a different world. It was the 640K is enough world, and nothing was protected. It crashed all the time. You had TSRs or terminate and stay resident hacks on top of things that would cause configuration problems. All the hardware was manually configured in your auto exec. So it was a very different world. But
the code is still the same, similar.
You could still write it. My earliest code there was written in Pascal. That was what I had learned kind of at an earlier point.
So between BASIC and C++, there was Pascal.
So when BASIC assembly language, and some of my
Take a step back.
My intermediate stuff was, you had to for performance. BASIC was just too slow. So most of the work that I was doing as a contract programmer in my teenage years was assembly language. But
then you wrote games in assembly?
Yeah, complete games in assembly language. And it's thousands and thousands of lines of 3-letter acronyms for the instructions.
That's you don't earn the once again greatest programmer ever label without being able to write a game in assembly. Okay.
But that's again, everybody serious wrote their games in assembly language. It was kind of
everybody's serious. You see what he said? Yeah. Everybody's serious. Yeah.
It was an outlier to use Pascal a little bit, where there was one famous program called Wizardry. It was like one of the great early role-playing games that was written in Pascal, but it was almost nothing used Pascal there. But I did learn Pascal, and I remember doing all of my like to this day, I sketch in data structures. When I'm thinking about something, I'll open up a file and I'll start writing struct definitions for like how data is going to be laid out. And Pascal was kind of formative to that because I remember designing my RPGs in Pascal record structures and things like that. And so I had gotten a Pascal compiler for the Apple IIgs that I could work on. And the first IBM game that I developed, I did in Pascal. And that's actually kind of an interesting story, again, talking about the constraints and resources where I had an Apple IIgs. I didn't have an IBM PC. I wanted to port my applications to IBM because I thought I could make more money on it. So what I wound up doing is I rented a PC for a week and bought a copy of Turbo Pascal. And so I had a hard 1 week, and this was cutting into what minimal profit margin I had there. But I had this computer for a week. I had to get my program ported before I had to return the PC.
Yeah.
And that was kind of what the first thing that I had done on the IBM PC and what led me to taking the job at Softdisk.
And Turbo Pascal, how's that different from regular Pascal? Is it a different compiler or something like that?
So it was a product of Borland, which before Microsoft kind of killed them, they were the hot stuff developer tools company. You had Borland, Turbo Pascal, and Turbo C, and Turbo Prolog. I mean, all the different things. But what they did was they took a supremely pragmatic approach of making something useful. It was one of these great examples where Pascal was an academic language, and you had things like the UCSD-P system that Wizardry was actually written in, that they did manage to make a game with that, but it was not a super practical system. While Turbo Pascal it was called Turbo because it was blazingly fast to compile. I mean, really ridiculously 10 to 20 times faster than most other compilers at the time. But it also had very pragmatic access to, look, you can just poke at the hardware in these different ways. And we have libraries that let you do things. And it was a perfectly good way to write games. And this is one of those things where people have talked about different paths that computer development could have taken, where C took over the world for reasons that came out of Unix and eventually Linux. And that was not a foregone conclusion at all. And people can make real, reasoned, rational arguments that the world might have been better if it had gone a Pascal route. I'm somewhat agnostic on that, where I do know from experience it was perfectly good enough to do that. And it had some fundamental improvements, like it had range-checked arrays as an option there, which could avoid many of C's real hazards that happened in a security space. But C won. They were basically operating at about the same level of abstraction. It was a systems programming language. But
you said Pascal had more emphasis on data structures. In the tree of languages, did Pascal come before C?
They were pretty contemporaneous. So Pascal's lineage went to Modula 2 and eventually Oberon, which was another Nicholas word, kind of experimental language. But they were all good enough at that level. Now, some of the classic academic-oriented Pascals were just missing fundamental things like, oh, you can't access this core system thing because we're just using it to teach students. But Turbo Pascal showed that only modest changes to it really did make it a completely capable language. And it had some reasons why you could implement it as a single-pass compiler, so it could be way, way faster, although less scope for optimizations if you do it that way. And it did have some range checking options. It had a little bit better typing capability. You'd have properly typed enum sorts of things and other stuff that C lacked. But, C was also clearly good enough, and it wound up with a huge inertia from the Unix ecosystem and everything that came with that.
Garbage collection?
No, it was not garbage collected.
It's the same kind of thing as C.
Same manual. So you could still have your use after freeze and all those other problems, but just getting rid of array overruns, at least if you were compiled with that debugging option, certainly would have avoided a lot of problems and could have a lot of benefits. But so anyways, that was the next thing. I had to learn C because C was where it seemed like most of the things were going. So I abandoned Pascal and I started working in C. I started hacking on these hardware things, dealing with the graphics controllers and the EGA systems. And what we most wanted to do, so at that time we were sitting in our darkened office playing all the different console video games, and we were figuring out what games do we want to make for our Gamer's Edge product there. Mm-hmm. And so we had one of the first Super Nintendos sitting there, and we had an older Nintendo, and we were looking at all those games. And the core thing that those consoles did that you just didn't get on the PC games was this ability to have a massive scrolling world, where most of the games that you would make on the PC and earlier personal computers would be a static screen. You move little things around on it and you interact like that. Maybe you go to additional screens as you move. But arcade games and consoles had this wonderful ability to just have a big world that you're slowly moving your window through. And that was, for those types of games, the kind of action, exploration, adventure games, that was a super, super important thing. And PC games just didn't do that. And what I had come across was a couple different techniques for implementing that on the PC. And they're not hard, complicated things. When I explain them now, they're pretty straightforward, but just nobody was doing
You sound like Einstein describing his 5 papers is pretty straightforward. I understand, but they're nevertheless revolutionary. So side scrolling is a game changer.
Yeah, and it's scrolling.
It's a genius invention.
Side or vertical, and
right.
And some of the consoles had different limitations about you could do one but not the other, and there were similar things going on as advancements even in the console space where you'd have. Like the original Mario game was like just horizontal scrolling, and then later Mario games added vertical aspects to it and different things that you were doing to explore, kind of expand the capabilities there. And so much of the early game design for decades was removing limitations, letting you do things that you envisioned as a designer, you wanted the player to experience, but the hardware just couldn't really, or you didn't know how to make it happen. It felt impossible.
You can imagine that you want to create like this big world through which you can side scroll, like through which you can walk. And then you ask yourself a question: how do I actually build that in a way that's like the latency is low enough? The hardware can actually deliver that in such a way that it's a compelling experience.
Yeah, and we knew what we wanted to do because we were playing all of these console games, playing all these Nintendo games and arcade games. Clearly, there was a whole world of awesome things there that we just couldn't do on the PC, at least initially. Because every programmer can tell, it's like if you want to scroll, you can just redraw the whole screen. But then it turns out, well, you're going 5 frames per second. That's not an interactive, fun experience. You want to be going 30 or 60 frames per second or something. And it just didn't feel like that was possible. It felt like the PCs had to get 5 times faster for you to make a playable game there. And interestingly, I wound up with 2 completely different solutions for the scrolling problem. And this is a theme that runs through everything, where all of these big technical advancements, it turns out there's always a couple different ways of doing them. And it's not like you found the one true way of doing it. And we'll see this as we go into 3D games and things later. But so the first set of scrolling tricks that I got was the hardware had this ability to, you could shift like inside the window of memory. So the EGA cards at the time had 256 kilobytes of memory, and it was awkwardly set up in this planar format where instead of having 256 or 24 million colors, you had 16 colors, which is 4 bits. So you had 4 bit planes, 64K a piece. Of course, 64K is a nice round number for 16-bit addressing. So your graphics card had a 16-bit window that you could look at, and you could tell it to start the video scan out anywhere inside there. So there were a couple games that had taken this approach of you could make a 2x2 screen or a 1x4 screen, and you could do scrolling really easily like that. You could just lay it all out and just pan around there, but you just couldn't make it any bigger because that's all the memory that was there. The first insight to the scrolling that I had was, well, if we make a screen that's just one tile larger, we usually had tiles that were 16 pixels by 16 pixels, the little classic Mario block that you run into. Lots of art gets drawn that way. And your screen is a certain number of tiles. But if you had one little buffer region outside of that, you could easily pan around inside that 16 pixel region, and that could be perfectly smooth. But then what happens if you get to the edge and you want to keep going? The first way we did scrolling was what I called adaptive tile refresh, which was really just a matter of you get to the edge and then you go back to the original point and then only change the tiles that are different between where it was. In most of the games at the time, if you think about sort of your classic Super Mario Brothers game, you've got big fields of blue sky, long rows of the same brick texture, And there's a lot of commonality. It's kind of like a data compression thing. If you take the screen and you set it down on top of each other, in general, only about 10% of the tiles were actually different there. So this was a way to go ahead and say, well, I'm going to move it back, and then I'm only going to change those 10, 20, whatever percent tiles there. And that meant that it was essentially 5 times faster than if you were redrawing all of the tiles. And that worked well enough for us to do a bunch of these games for Gamer's Edge. We had a lot of these scrolling games like Slordax and Shadow Knights and things like that we were cranking out at this high rate that had this scrolling effect on it. And it worked well enough. There were design challenges there where if you made, the worst case, if you made a checkerboard over the entire screen, you scroll over one and every single tile changes and your frame rate's now 5 frames per second because it had to redraw everything. So the designers had a little bit that they had to worry about. They had to make these relatively plain looking levels, but it was still pretty magical. It was something that we hadn't seen before. And the first thing that we wound up doing with that was I had just gotten this working, and Tom Hall was sitting there with me, and we were looking over at our Super Nintendo on the side there with Super Mario 3 running, and we had the technology, we had the tools set up there, and we stayed up all night, and we basically cloned the first level of Super Mario Brothers.
Performance-wise as well?
Yeah. And so we had our little character running and jumping in there. It was, it wasn't, it was close to pixel accurate as far as all of the backgrounds and everything, but the gaming was just stuff that we cobbled together from previous games that I had written. I just kind of like really kit bashed the whole thing together to make this demo. And that was one of the rare cases when I said I don't usually do these all-night programming things. There's probably only 2 memorable ones that I can think about. One was the all-nighter to go ahead and get our Dangerous Dave and copyright infringement is how we titled it, because we had a game called Dangerous Dave, which running around with the shotgun shooting things, and we were just taking our most beloved game at the time there, the Super Mario 3, and sort of sticking Dave inside that with this new scrolling technology that was going perfectly smooth for as it ran. And Tom and I just kind of blearily the next morning, kind of left, and we left a disc on the desk for John Romero and Jay Wilbur to see, and just said, "Run this." And we eventually made it back in later in the day, and it was, like they grabbed us and pulled us into the room, and that was the point where they were like, "We got to do something with this. We're going to make a company. We're going to go make our own games." Where this was something that we were able to just kind of hit them with a hammer of an experience, like, wow, this is just like so much cooler than what we thought was possible there. And initially, we tried to get Nintendo to let us make Super Mario 3 on the PC. That's really what we wanted to do. We were like, hey, we can finish this. It's line of sight for this will be great. And we sent something to Nintendo, and we heard that it did get looked at in Japan, and they just weren't interested in that. But that's another one of those, life could have gone a very different way, where we could have been like Nintendo's house PC team, at that point.
And define the direction of,
Wolfenstein
and Doom and Quake could have been a Nintendo creation.
Yeah. So at the same time that we were just doing our first scrolling demos, we reached out to Scott Miller at Apogee and said, it's like, hey, we do want to make some games. These things that you think you want, those are nothing. What do you see what we can actually do now? This is going to be amazing. And he just like popped right up and sent a check to us, where at that point, we still thought he might be a fraud, that he was just lying about all of this, but he was totally correct on how much money he was making with his shareware titles. And this was his kind of real brainstorm about this, where shareware was this idea that software doesn't have a fixed price. If you use it, you send out of the goodness of your heart some money to the creator. And there were a couple utilities that did make some significant success like that. But for the most part, it didn't really work. There wasn't much software in a pure shareware model that was successful. The Apogee innovation was to take something, call it shareware, split it into 3 pieces. You always made a trilogy, and you would put the first piece out, but then you buy the whole trilogy for some shareware amount. which in reality, it meant that the first part was a demo where you kind of like the demo went everywhere for free and you paid money to get the whole set, but it was still played as shareware and we were happy to have the first one go everywhere. And it wasn't a crippled demo where the first episode of all of these trilogies, it was a real complete game and probably 20 times as many people played that part of it, thought they had a great game, had fond memories of it, but never paid us a dime. But enough people were happy with that where it was really quite successful. And these early games that we didn't think very much of compared to commercial quality games, but they were doing really good business, some fairly crude things, and it was good business. People enjoyed it, and it wasn't like you were taking a crapshoot on what you were getting. You just played a third of the experience, and you loved it enough to handwrite out a check and put it in an envelope and address it and send it out to Apogee to get the rest of them. So it was a really pretty feel-good business prospect there because everybody was happy. They knew what they were getting when they sent it in, and they would send in fan mail. If you're going to the trouble of addressing a letter and filling out an envelope, you write something in it, and there were just the literal bags of fan mail for the shareware games. So people loved them.
I should mention that for you, the definition of wealth is being able to have pizza whenever you want. For me, there was a dream because I would play shareware games over and over, the part that's free over and over. And it was very deeply fulfilling experience. But, I dreamed of a time when I could actually afford the full experience. And this is kind of this dreamland beyond the horizon where you could find out what else is there. In some sense, even just playing the shareware was it's the limitation of that. Life is limited. Eventually we all die. In that way, shareware was like somehow really fulfilling to have this kind of mysterious thing beyond what's free always there. It's kind of I don't know. Maybe it's because a part of my childhood is playing the shareware games. That was a really fulfilling experience. It's so interesting how that model still brought joy to so many people.
Yeah.
The 20x people that played it.
Yeah. I felt very good about that. And I would run into people, it's like, that would say, oh, I loved that game, that you had early on, Commander Keen, whatever. And no, they meant just the first episode that they got to see everywhere.
That's me. I played the crap out of Commander Keen.
And that was all good.
Yeah. Yeah.
But so we were in this position where Scott Miller was just fronting us cash and saying, yeah, make a game. But we did not properly pull the trigger and say, all right, we're quitting our jobs. We were like, we're going to do both. We're going to keep working at Softdisk, working on this. And then we're going to go ahead and make a new game for Apogee at the same time. And this eventually did lead to some legal problems, and we had trouble. It all got worked out in the end, but it was not a good call at the time there.
And your legal mind at the time was not stellar. You were not thinking in legal terms.
No, I definitely wasn't. None of us were. And in hindsight, yeah, it's like, how did we think we were going to get away with like even using our work computers to write software for our breakaway new company? It was not a good plan.